Here, I show you a proper workaround to solve the distorted moving background issue in ComfyUI. We fully separate Jenna from the background using the Birefnet workflow from show before feeding her into the float engine. To achieve this, we use my already modified workflow where I combined the float-optimized pipeline with the Birefnet 3-in-1 background remover. As you can see right here on the canvas, the separated avatar gets directly feeded inside the float-optimized advanced workflow. Alternatively, you can also use the example workflow which came with the installation and do those steps separately. First, you generate the avatar without a background, and then you feed it directly into the float engine as an independent building block. Since we are running this on an 8GB VRAM card like my Tesla P4, memory management is key. That is why you can use the Purge VRAM node right after the Birefnet stage. This completely frees up the VRAM before the heavy float model is loaded into the GPU, preventing any out-of-memory crashes. Additionally, if you already have a pre-rendered image or a previously generated version of a float-talking avatar with a distorted background, and you want to get rid of that background entirely, you can use this post-processing background removal workflow. Just feed your existing video frames directly back into the Birefnet stage to isolate the avatar retroactively and clean up the sequence. Now, one important thing to point out, under certain conditions you might notice that right at the beginning, Jenna gets slightly distorted. I noticed this directly at the shoulder area. In the very first frames, she briefly disappears or clips out. Don't worry, this is a known pipeline behavior and stabilizes immediately after. Keep two things in mind when using this pipeline. First, Jenna might briefly distort or clip near the shoulders in the very first frames. Don't worry, this is normal and stabilizes immediately. Second, standard MP4 videos do not support transparent backgrounds. If you need transparency, you can export a WebP file without sound and add your audio later in a video editor. Alternatively, you can render an MP4 with a green screen background to keep the audio synced and remove the green color later. From here, you should be good to go. This video was kept simple for a reason. No endless talking, just real, visual proof. I created this because I know how frustrating the current AI landscape can be with its paywalls, and I wanted to share the pure joy of a different independent path. It is amazing how easily you can run advanced AI locally on your own computer using ComfyUI and the right models. You don't need the latest high-end tech. This entire pipeline runs smoothly on a generic i7 processor, 24GB of RAM, and an older budget-friendly Pascal architecture GPU, NVIDIA Tesla P4 with 8GB VRAM. Most importantly, no monthly subscriptions, no 25 free credits per day limits. We all know those daily tokens are gone in minutes when you are firing a complex workflow over and over, tweaking nodes to get the exact result you want. Running it locally means infinite retries and zero cost. To make this specific 8GB VRAM setup completely stable and production-ready, we integrated two crucial fixes: Float for flawless animation stability and Birefnet for clean distortion-free background removal. Here is a valuable pro tip shared by the community. Consider running this setup on Ubuntu Linux. Please note, this is not a critique or evaluation of Windows or Linux. Both operating systems are fantastic in their own way, and they complement each other seamlessly in any modern creator's workflow. This tip is purely based on technical facts, benchmarks, and real user experiences within the open source community, because ComfyUI, PyTorch, and most deep learning frameworks were originally built for Linux server environments. They run natively and with maximum optimization under Ubuntu. Think of Windows 11 as your amazing everyday powerhouse, a reliable horse that can literally do anything you throw at it. It is fantastic. However, for daily desktop tasks and features, it naturally requires 2 to 3 GB of VRAM just to keep things running. Ubuntu, on the other hand, is where we go to press out every last drop of performance. It keeps your VRAM almost entirely free and manages system memory with direct, surgical precision. This highly efficient RAM to VRAM data transfer is the ultimate community secret weapon to squeeze every single megabyte of power out of an 8GB card without crashing. Could we tweak Windows to achieve something similar? Technically, yes. And trust me, I know exactly what that feels like. I've been there early on in my tech journey. I spent countless hours setting up DIY eGPUs via PCIe slots and smart card readers using the legendary bstock. I used Nando Fariva's software and ASL compilers to manually patch custom DSDT tables just to get a graphics card recognized by Windows. Back then it was an absolute nightmare. It worked, but nearly every single Windows update would break the entire setup, forcing you to start all over again. Thankfully, over the years, both Windows and Ubuntu developers listened to user requests. Today, integration has become beautifully flawless and mostly plug-and-play. But why go through that complicated patching madness today just to free up a bit of memory? The average user doesn't want to go to war with their operating system or risk bricking things with custom table flashing. They want a click it, run it experience. And that is exactly what Ubuntu offers right out of the box for this specific pipeline. No hacks required, just native, stable performance, no paywalls, no restrictions, just pure local creative freedom. Thank you for watching.